HHO, if you compress it, it snaps back into water at a certain PSI, and it's very low PSI. If you have the time and the money to do all the research that's really already been done, then you would spend, a few $1,000,000 to come up with some of this technology that Mr. DeRosa has already been the pioneer in for some 20 years. And he's also here in Clearwater, Florida. And that's called MagnaGas. If you want to go to magnagas.com, you can learn about DeRosa. He takes waste fluids from junkyards and whatever, even wastewater, and electrolyzes it and extracts the HHO out of it. But his process of taking the HHO with ARC technology, and then how he processes the hydrogen atoms on the way through the gas flows is secret, but it's leaps and bounds above what we're trying to put in automobiles. He runs his Ferrari on it.
What is the
no gasoline.
What's the operating principle of HHO as you understand it in this unit?
Say again?
What is the operating principle of this unit?
It's the same electrolyzers with the electrolyte in it. It's just at a higher voltage and still 15 amps, but at 220 volts, you get enough to cut the parts out of automobiles all day long out of 2 liters of water.
Yeah, I know.
And is it true that it's scalable from 300 degrees to 4,000 degrees?
The flame temperatures?
Yeah.
It depends on what you contact that with. It'll go as high as 12,000 degrees on tungsten.
Why is it scalable? Why can it go from 300 to 12,000 without any intervention?
It comes back down to, I'm not a physicist, or I don't really understand too much about it, but it's how the molecules of the hydrogen react with the molecules of the material you're burning in. It could be submarine steel, or it could be aluminum, or it could be copper. It comes up with the same kind of straight, clean cut because the flame will automatically adjust to the atoms it's cutting through. Don't ask me to explain it any more than that, because that's about all I understand about it. You could take unsimilar items like iron and brick, or glass and stone, and whatever, and fuse them together with this kind of gas. Yes.
Excuse me, can you repeat the question so everybody can hear?
Okay. He asked if I use this converter on a vehicle. Yes, we've got them in several. And what was your other question? The improvement is, you have to understand how many liters per minute does this system make, or does that system make, or does that system make. This will increase that liter per minute output by about 25%. But the more important part is it reduces the draw, the current draw, because you're losing less energy in your electrolysis process. You're losing less heat energy. So this makes the system more efficient. And you get better production and less heat loss, so it's less draw on your alternator. You take about, okay, the amps in, 15 amps in, amps coming out is 8 to 10 at 150 volts.
How much do they cost?
These are $650. And well worth it, especially if you're, if you are using one of the bigger electrolysis systems you see around here today. This is worth its weight in gold. For truckers, anybody who uses lots of fuel, it'll make the price of the electrolyzer systems here is all fair and within reason, but every one of them should have this kind of thing, because it just improves the efficiency so much more. You get better gas, less heat loss. One more question.
You got 12 volts on one side and 150 volts on the other side?
Right.
Does it say DC?
Yes, it's DC and it's rectified. It comes out at 1,000 hertz. of DC square wave. Very clean, you know, oscope, if you watch the sine waves and the square waves on oscope, this thing puts out the cleanest square wave I've ever seen. And I don't know if you know about the little, if you watch any of the output signals from any of the electronic controllers, once you start putting amps through them, the square wave goes bouncing all over the place. They're not made heavy duty like this. Okay, back to you, Joe. Thank you very much.